Hi everybody, in this video I'm going to show you how to use loops in App Inventor. I'll be doing that using just a simple example that loops through a series of numbers and just puts them on the screen. The whole point is to just make it as straightforward as possible so that you can see a few different examples of how to use loops and why they might be valuable in programming. So first of all, I'm going to do something without loops just to show you sort of the value, so you can see the value in using them. But I'm going to have to set up, I'm still going to have to set up a user interface just to make something show up on the screen. So I'll need a label, and this label is just going to say count to, and it's just all the app is going to do is just count up to a certain number in a couple of different ways. I'll make that a little bit bigger so you can see what I'm doing. I'll add a text box because later we're going to need to be able to tell it what number to count up to. And for now, I'll just add one button. And the first thing I'll do is not using loops at all. I call this button count 10. It'll say count to 10. And what I want to do, and what I'll do each time I do something on here, what I'm going to do is have it print a number and skip a line, print a number and skip a line. So the simplest and most straightforward way to do that would just be to tell it what numbers to print. So the count 10 button would just set the label text property, and I would just tell it to say 1, and then I'll actually skip a line using \n. So the backslash is the one, it's the slash right above the enter key. That's in most programming languages what you can use as a new line character, and it works in App Inventor. So it'll skip a line. So I'll say 2, skip a line, and I'll just have it count to 10. And then I'll need an output label. So I'll add another label. Say label output. And I'll just make it blank at first. I don't want it to say anything. And then when I click the button, it should just count to 10. Pretty much the simplest thing you could do in App Inventor. I make sure my screen's up to date. Count to 10. It counts to 10. My numbers are a little big and in the way. What did I set? Label 1? Let me set my output label. There we go. All right. Let's count to 10 again. All right. So straightforward enough. All it does is you directly say what you're going to do. Here's the problem. What if you need to output more than a fixed data set? What if you need to, what if it's just a large data set? I mean, this is a really simple example where you're just printing out 10 numbers, but what if you needed to take user input and change the number that you were printing? Well, just typing it in a string block here doesn't really help. What if you wanted to count to 1,000? Or you wanted to print out 1,000 different data points? Again, that gets tedious. So there are ways using loops that you can generate data. What I'm going to add, before I go on to showing you how to use the loops to do that, is I'm also going to add a clear button. I'm going to start putting these buttons in a table arrangement. I think I'm going to end up with a bunch of them, so I'm going to say table arrangement 3 columns, 2 rows. Put this in there. And I'm also going to add another button. I know it'll be like the sort of, I want to keep it separate from the other ones because this one won't print anything. It'll be a clear button. So I'll say button clear. And when button clear is clicked, I just want to clear the output. So I'll set this to an empty string. So I should be able to count to 10 and then clear. It works. I should replace this text with clear. Okay. So I showed you the most straightforward but least flexible way to do that. However, it's often necessary to do more than just print out like a literal string of text. You usually state, like the program state in an app changes. So the next example will be an example with a loop. I'll add another button. I'll say button 10. I'll say count 10 loop. The text can say count 10 loop. So this will do the same thing as the first one, only count to 10, but it'll do it using a loop, just to show you how loops work in App Inventor. So this time, use when button count 10 loop is clicked. It's going to do the same thing as this one. So it's just going to set the output label. However, instead of directly typing it all in, what I'll do is get one of these for each number loops. So this is a for loop. This is also most programming languages have a structure like this, usually called a for loop. It's a definite loop. It repeats a definite number of times. So the way this works is you're going to tell it just basically how many times to repeat. It does that just by kind of counting. This is iteration number 1. This is iteration number 2. This is iteration number 3. And remember that word iteration that we've been using to describe a sort of another step in the process, usually another step in the process of building an app. Well, you can also use that word to describe an iteration inside of the program. Like we're going to repeat through this looping structure one more time. We're going to repeat this code one more time. So for each number, counting at 1 up to 10, because we want to count to 10, counting by ones, that's what this means. So we're starting counting at 1, we're going to count to 10, counting by 1. So just normal counting to 10. What I'm going to do is, no, not that. What I'm going to do is just get that number, whatever number you happen to be on, and I'm going to print it out, but I need to print it out with line breaks. Remember, I'm trying to combine that together into one big long text output with line skips. So what I actually have to do is I can't just put this there because they would all replace each other. If it'll just run through the loop, and the first time it'll be 1, the second time it'll be 2, the third time it'll be 3, but by the time you get to the end, it'll all happen so fast, it'll happen practically instantly. You won't even be able to see it, and it'll just say 10. And you won't know why. It actually went through all 10 numbers, you just couldn't see the first 9. So what I need to do is instead store each of those numbers. So I'll take a join block, and I'll join this output label text property, whatever it currently happens to be. So at first, just nothing. I'll join that with the number. I'll add one more space because what I'll need is to add that new line symbol, the /n. So what it's doing is it's producing this exact same thing. It starts with nothing because it'll just be an empty label. Remember, I set it to be empty. If I click on label output, its text property is empty. There's nothing there. Then for each number, starting at 1, counting up to 10, counting by ones, so just going in normal order, what it's going to do is say set label output dot text to the combination of what it used to be, nothing, plus the current number, 1, plus a line break, so it'll skip a line. Then the next time through the loop, this number is going to be 2, because it's just counting from 1 to 10. So it's going to combine together what it used to be, 1, with the current number, 2, and another line break. So you've got 1 space, 2 space, and then, or one new line, 2 new line. And then this number goes up to 3, it adds a 3, this number goes up to 4, it adds a 4. And that's it. So it does the same thing this does, but this was just a demonstration of how you could use a loop to accomplish the same thing. So I can still count to 10, but I can clear. I can count to 10 with a loop. Interesting thing about using a loop is that I can also count to 1,000 and it doesn't cost me any extra time typing over here. I don't know how it's going to display counting to 1,000, but apparently it'll do so with some lag. Probably just doesn't fit on the screen. And I crashed it. Well, you can see it tried to continue. It tried to continue going on. It reached up to 15. Let me wait. I'm sure it'll finish up eventually. It ran out of space. If I had made my screen scrollable, I'm sure I could scroll all the way down to 1,000. The whole point of that wasn't really to actually count to 1,000. The point was to just show that when I changed the ending condition for the loop, right, it ends at 1,000 now instead of 10. It changes what happens on the screen. So let me change this back to 10 so I can stop breaking my emulator. And this time I'm going to do another one, except this time I'll add user input. So not only will it be more flexible now because it uses a loop, but the flexibility will actually be functional in the app. So you can take input and the input can affect how many times the loop runs. So this time I'll add a button. I'll say count blank and I'm going to call this a for loop, so count blank for. So I'll use a for loop again, but I am going to demonstrate a different type of loop as well later. So that's why I'm specifying what type of loop. This is button count space for. Count blank. I'll call it a for loop. So when this one is clicked, it's going to look an awful lot like this one. So I'm even going to copy its code. However, I need a little bit more information. What I need is the input from this text box. So I'm going to create a local variable. I'll call it input, and I'll set that to text box.text. So I'm getting the input. And so this time, for every number from 1 to the input, I'm going to count by 1. So I'm going to count from 1 up to the input number, whatever you type in. It's still going to set label output.text. It's still going to set label output.text to whatever, to a combination of whatever it used to be plus the current step in the loop, but it's just going to stop looping instead of just stopping when it gets to a specific number like 10 that's set in advance. It'll be a number that the user inputs. So I can still count to 10. However, now I can clear and also count to 15. Right, it goes up to 15 because I now can just type in a number, and whatever I type in, that's what it prints. Right, so there's an example. Not only do you have more flexibility in how many times you repeat, but you can actually use user input to affect that. And then the last thing I want to show you, one more type of loop. These examples so far I've used for loops. You can actually accomplish a lot of the same things with a while loop, and while loops also have sort of, they do work a little bit differently, and so sometimes they're more useful in different kinds of situations. So first I'll set up my user interface, one more button, count blank while. This will be a while loop. Rename button count blank while. Right, and again, it's going to be really similar. I'm going to duplicate my code. However, this loop is going to have to change a bit. I'm not using a for loop anymore. This time I'll use a while loop. And a while loop still repeats, but instead of repeating a fixed number of times, like whatever happens to be typed here, it actually uses a condition, like a Boolean statement. And when while the Boolean statement is true, it keeps repeating. So while you put a specific number here, and it repeats that many times for a for loop. For a while loop, it'll keep repeating until that Boolean statement evaluates to false. When it evaluates to false, then it's going to stop. So that can be really useful for when like you're doing something in a program where conditions in the program, can change, and you don't know when they're going to change. But when they do, maybe some condition will be false, and then the loop stops. In this case, I'm actually just going to put numbers in there, so it's not, it's not going to look that much different from what we're doing here. But just know that this for loop repeats until up to this specific number. It says repeat from blank to blank. It repeats up to a specific number. A while loop repeats while some condition is true. So what I'm going to do is repeat while I actually need, so here's a slight difference here. the local variable number in the for loop is just sort of there by default in App Inventor. This local variable is just part of the block. I'm going to need to create my own new local variable to keep track of the sort of, it's called an iterating variable. It's just the variable that it's keeping track of your iterations. A for loop is a structure in the programming language that kind of keeps track of how many iterations you've done for you. With a while loop, we're going to have to keep track of it manually. So I'm going to add another variable. I'm going to call it number, just like this number. And I'll start it at 1, just like this one starts at 1. And then while that number is less than or equal to, so I'll say while that number is less than or equal to the input number, it's going to do all this stuff. Now, don't run it yet. It's not done. First, I want to explain why I have to use equal to. If I don't, well, I think I should just show you what happens if I don't later, and I will. But if I don't use equal to, it'll actually stop early. Remember, it's going to keep running while it's going to print. It's going to do this whole process of like setting the number or setting the text label to a combination of those numbers while this condition is true. If this was just less than when it got to the last number, like let's say you're counting to 10, when it got to 10, it's not less than 10 anymore. It would be false. This condition would actually be false. It would stop, so it wouldn't actually print 10. So you'd be printing from 1 to 10, and it wouldn't print from 1 to 10. So you need an equal to, so that, for example, you want to count up to 10. If you type in 10, it'll be equal to 10, right? Less than or equal to 10. That's why I need the equal sign, this one, the less than or equal. And it will actually still print. So the other thing I need to mention is that this doesn't increase or increment your iterating variable for you. That is, this number, where in the for loop, it was just sort of keeping track of this and going one at a time, 1, 2, 3, 4, 5, etc., on its own. In this case, we're going to have to do that manually. So you have to set. This is each time through the loop, each repeat, each iteration. You have to set the number. That's the iterating variable number, just like up here. Set the number to itself plus 1. That's how you iterate things, as you set a number to itself plus some other number. So whatever it was before, it's now going to be 1 greater, just like up here, it's counting just 1 at a time. This is manually counting 1 at a time. So now, got everything in place. If you ran it without doing this, you would actually have an infinite loop. It would just run forever. It would probably crash App Inventor. So make sure you iterate. Make sure you increment your iterating variable. Set number to itself plus 1, and then it should increase that number each time. All right, so let's try. And just having that disconnected might have even crashed. I don't know what crashed it. The emulator crashes sometimes. Let's see if I can get it back. Okay, so let's see if this works. So just like, so before, I was able to just count to 10. I could count to 10 with a loop. I could count to other numbers using a for loop. And now I can also count using a while loop. Notice the output for the while loop counting to the input number. Let me clear that. Right, is the same as the for loop. Right, it does the same thing in this case because I told it to do the same thing, just manually increasing the number. Either way, you've got these loops that repeat the code that's inside them. Right, this process happens however many times you specify. Either you say just repeat this number of times counting by some number, or you can say repeat until you repeat as long as this condition is true. In this case, the number is less than the one you're counting up to, which is really the same effect in the end. But you can use these different ways of setting it up to accomplish different things. Specifically, you can set this. You can use this when you know what you want to count up to, or when you know how many times you just want to repeat something. You just tell it to repeat a certain number of times. And then you can use this when you aren't sure how many times you want to repeat, even if you didn't know what this condition, when this condition was really going to be true. I mean, we kind of did, right? It was true when you got to the last number, but you could put a condition in here that might just keep running until some program state changes, and then the loop ends automatically. So this can be useful for different reasons. So there's your introduction to loops. I hope that was helpful. See you next time.